So let's start with section 5.1, the antiderivative and integral or indefinite integral. Integral or integration, the integration, keep in your mind, is going to be the opposite of the derivative. So let's start. If we have a given function f on some interval I, f, capital F, we're going to call it antiderivative if. Antiderivative if you take in the derivative for the capital F, it's going to go back to the original function. So if you take, because you're going to do the antiderivative, you're going to get a new function. So if you take the derivative for the new function, which is f, you're going to go back to the original function. So it's the opposite of the derivative. It's going to be antiderivative. This is like an example. If we have f of x equal x squared, the antiderivative, and we're going to learn how to do that. The antiderivative for x squared is going to be x cubed over 3. Okay? This is the antiderivative. Let's check that. So if I took the derivative for this function, now if I want to say, okay, if I want to take the derivative for x cubed over 3, it's going to be quotient. So you're going to say, okay, the bottom part times the derivative for the top, which is 3x squared, minus the top times the derivative of the bottom is 0 over 3 squared. Simplify this one. This is 0. 3 times 3 is 9. Cancel with the 9. So the left is x squared. So if I took the derivative for the f function, it's going to go back to the original function, which is x squared. That's why the antiderivative is going to be the opposite. But here's the question. So if I took the derivative for the f, that means this one is the derivative for f. It's going to go back to the original function, which is f of x. But there's a question. So if I assume that there is a number here, here is the f function. If I assume that there is a number here, and if I took the antiderivative for this one, if I took the antiderivative for this one, it's going to be the same thing, equal x squared plus 0, because the derivative for the constant is going to be 0. So they say, okay, now we have different f function. This one, if I took the antiderivative, is going to go back, or the derivative is going to go back also to x squared. Every time I'm changing the number here, take the derivative is going to go back to the original function x squared. In this case, we can't assume that there's a certain number here. We're just going to say, okay, let's assume the number is c in general. So if they give you an initial condition, you can find how much the c, and we're going to take an example. So every time when you're taking the antiderivative, you have to add the constant c. If they gave you the initial condition, yes, you can plug in the initial condition here to get how much is going to be the constant c. And then in this case, you're going to see the original function by finding the constant c. That means with the constant c is going to be all the possible antiderivatives of the function f of x equal x squared, because we have more than one number. If we keep adding it, this number is going to be the same derivative. In this case, we can't assume that it's 5, 6. We have just to put a constant c. I'm going to write down this next board. I need you to just take a picture, because we're going to use the rule. The first rule, if you check here, I wrote the rules for the derivative, and it's going to be the antiderivative. So the derivative for any constant, which is any number, is going to be 0. The derivative for any constant is going to be 0. That means the integral, which is being the antiderivative, we're not going to say antiderivative anymore, we're going to say integral. The integral of 0 dx is going to be equal the constant. You see, it's going to go back. The derivative for the c is going to be 0, for constant is going to be 0. The derivative for a 0 is going to be, the integral for the 0 is going to be, go back to the constant. The derivative for x equal 1. The integral for 1 dx is going to be x, and you have to add the constant c. Always you have to add the constant c. Now, if you're taking the derivative for this one, the constant is going to be 0. The derivative for the x is going to be 1. So it's going to go back to the original function 1. Now, the derivative for xn is going to be xn minus 1. The integral for xn dx is going to be xn plus 1 over n plus 1 plus c. The derivative for kx is going to be k, because the derivative for x is going to be 1. K times 1 is going to be k. The integral for k dx is going to be kx. You have to add the x plus c. Always, when you're taking the integral, you have to add the constant c. Now, the derivative for the sine is going to be cosine. The integral for the cosine is going to be sine. Just the opposite. The derivative for cosine, negative sine. What about if we need to find the integral for sine x dx is going to be negative cosine plus c. So you have to be careful, because here's going to be the mistakes. The derivative for the cosine, for the sine cosine. The integral for cosine is going to be sine. The derivative for cosine is negative sine. There's a negative sign here. Negative sine x. The integral for the sine is going to be negative cosine plus c. The same thing.
Why is it the integral of sine and not negative sine?
Because what about if you got integral for the sine? The negative sign, you're going to take it out the integral. The negative sign is going to go out the integral. We're going to check that with an example. You're going to go back to the integral for the sine. So in this case, it's going to go back to the cosine, and the negative sign is going to go down. Okay, plus c. The same thing. The integral for the derivative for the tangent secant square. What about the integral for the secant square x dx is going to be tangent. It's going to go back to the tangent function. The derivative for the cotangent x, negative cosecant x. The integral for cosecant square x is going to be negative cotangent. The derivative for cosecant x, negative cosecant cotangent. The integral for this part, cosecant x, cotangent x dx is going to be negative cosecant x plus c. Always you have to add the constant c. The derivative for the secant x, secant tangent. The integral for secant tangent x dx is going to be secant x plus c. So we're going to work with this side, but I need to show you the difference between the derivative and the integral. The derivative for e to the x, the exponential function, is going to be e to the x. The integral is going to be e to the x plus c. The derivative for a to the x is going to be ln to the a, the base a. And you can just add down the function a to the x. The integral from a to the x is going to be 1 over ln a ax plus c. This is really important function. The derivative for the ln x is going to be 1 over x. But there's a condition. Why the condition is says always x greater than 0? Why for this function? Ln x, why always we have to take the x greater than 0? Why we can't take negative number? The integral for 1 over x is going to be ln y. You see the result? Absolute value of x. Y. The absolute value, that means the result always going to be ln to a positive number plus c. Why we can't take negative number? For the ln function. Why we can't take negative number?
It is undefined.
It's undefined. So that's why we put a condition always x greater than 0. Because the negative number is going to be undefined. So let's keep going. We have 2 notes. The derivative of a constant times a function. Always, we're going to take the constant out and find the derivative for the function. Now it's going to be the same thing if we have integral. The integral with k, which is a number, k is any number, times the function dx. You're just going to take the k outside the integral and find the integral for the f of x dx. The integral, the derivative for two functions, the addition of two functions, or the difference between two functions is going to be the derivative for the first one plus or minus the derivative for the second function. Okay? The integral is going to be the same thing. The integral for the sum or difference between two functions is going to be the integral for the first one and the integral for the second one. What about if we have multiplication? You can't do that with multiplication. It doesn't mean the integral of the multiplication of two functions is going to be the same thing, the integral for the first function times the integral for the second function. So you can't do that. Let's check these examples. The first example, they ask you to find the integral for x to the power 4. The integral for x to the power 4, you're going to use rule number 3. You're just going to add 1 here. That means this one is going to be x 4 plus 1 over 4 plus 1. And always when you check in the integral, you have to add the c. That means this one is going to be equal x to the power 5 over 5 plus c. So this is the integral for this function, x to the power 5 over 5 plus c. What about the second one? How are we going to find the integral for the second one? You're going to do exactly the same thing, but we're going to check here x cubed on the bottom part. So it's easier for us if we rewrite this one as an integral to the x to the negative 3 dx. In this case, I can use the same rule, rule number 3, because now I have a number, a variable with exponents. So I'm just going to add 1 here and divide by, so this one is going to be x to the negative 3 plus 1 over negative 3 plus 1. And you have to add the c. That means this one is going to be equal x to the negative 2 over negative 2. And you have to add the c. Now write down the 2 on the bottom. So it's going to be positive, or you can keep it, this one is going to be also right. So this one is going to be 1 over, or you can say negative 2 here. And here is x squared plus c. So this one also is going to be right. So find the integral, and again, I'm not going to say antiderivative anymore. Integral, it's mean the antiderivative.
Sir, it's blurry. We can't see it.
Okay, that's good. So now we're going to find the integral for the square root of x. Okay, I know that everyone hates radical, square root, cubic root. So the easy way to find the integral for square root is going to say it's the same thing, the integral of 1x 1 over 2 dx. Now it's easier to find the integral for this one because you're just going to add 1 here. That means it's going to be x 1 over 2 plus 1 and divide by 1 over 2 plus 1. And always you're going to add the constant c. Now on the side, let's add these two numbers. So it's going to be 1 over 2 plus 2 over 2. That means it's going to be 3 over 2. That means this one is going to be equal x to the 3 over 2 divided by 3 over 2. 3 over 2, 3x. Three over 2 plus c. I can write down this just flip the bottom part, so it's going to be 2 over 3 x 3 over 2 plus c. So that's is going to be the integral for the square root of x. The same thing if we have the integral of 3x dx, 3x dx. 3 is a constant. So I can take the 3 outside the integral. So this one is going to be the same thing, if 3 integral x dx. Now by using the second rule, the integral or the third rule, the integral for the x, the exponent here is 1, so you're going to add 1. That means it's going to be 3. Here's x, it's going to be 1 plus 1 over 1 plus 1, and you have to add the c. That means it's going to be 3, and here's x squared over 2 plus c. Then you can write down as a 3 over 2 x squared plus c. So here's the integral for 3x dx. So every time when you have a constant, just take it outside the integral and find the integral for what you have here. X squared, x cubed, x to the power 4 will be the same thing. Number 5, the integral of 1 plus x. Be careful, this is two functions. 1 and x. We're going to use the second note. If we have the integral of the sum between two functions, this one is going to be equal to the integral of 1 dx plus the integral of x dx. Yeah, the integral of 1 dx is going to be x, and always we have to find the constant c. We're going to add the constant c. I'm going to say c1 because we're going to add two constants. So I'm going to say, okay, it's equal c1 plus the integral for x dx. For the x, you're going to add, here's 1, you're going to add 1. So it's going to be x squared over, let's add it down, 1 plus 1 over 1 plus 1. And also you have to add another constant, you're going to say c2. And you see c1 and c2 because we find the integral for this part, and we're going to find the integral for the second part. So I have to add two different constants. In this case, this one is going to be x plus c1 plus x squared over 2 plus c2. But let's check. C1 and C2 is a constant, and we can't say like, okay, it's a constant, and we don't know which one. It's going to be 2, 4, negative, number, positive. So I can combine these together as a constant in general, which is C equals C1 plus C2. That means this one plus this one, I'm just going to add down as a general, constant in general. So maybe x plus x squared over 2 plus c. And if they gave you initial conditions, in this case, you can find c1 and c2. So every time when you have to find the integral for more than one function, like this example. So find the integral for the first one, find the integral for the second one, and do not add c1 and c2. Just the last term, you're going to add a c, okay? So if you have 3 terms, you're going to find the first one, the second one, the third one, and the last part, you have to add a constant c, okay? So that's the difference. And we're going to do another example similar to this one.
That example, do we need to combine the x, like to simplify it?
You can simplify it, or you can keep it like this. It's fine. Like you can multiply by 2, it's going to be 2x, x squared, and 2c. So, but the main thing, the integral for this function is going to be this one. So you don't have to simplify it. Of 2 sine x dx. Again, here's k is going to go out. So it's going to be the same thing. It's 2 integral of sine x dx. And it's going to be equal, here's the 2, The integral of sine x dx is going to be what? Sine x dx is going to be cosine. Sine x dx is negative cosine. That's mean here is the 2. The integral of sine is negative cosine x, and you have to add the c. That means it's going to be negative 2 cosine x plus c. That's it for this example. So let's check these 2 examples. Find the derivative of this one. You're gonna say, okay, how am I gonna solve this one? Give me the same thing like the previous one. You're gonna find the derivative for, sorry, the integral for the first one, the second one, the third one, and the fourth one. And the last thing, you're gonna add the constant c. So this one is going to be the same thing. It's the integral for 2x cubed dx. I'm doing in details, but you don't have to do the details. You're just gonna say, okay, I'm gonna find the integral for x cubed. So it's gonna be minus the integral of 3x squared dx. And then you're gonna say plus the integral of 4x dx.
So Professor, in the beginning you wrote 2x to the power
Oh,
of 2 instead
it's
of-
I think it's a cubed.
Yeah.
It's a cubed. Because if it's not a cubed, we can combine these together. And then it's minus the integral of 6 dx. That means going to be 2 integral of x cubed dx minus 3 integral of x squared dx plus 4 integral for x dx and minus the integral 6, the integral for the x. 6 integral for dx. So this one is going to be 2. The integral for x cubed is going to be x cubed plus 1 over 3 plus 1 minus. Here is the 3. X squared is going to be x 2 plus 1 over 2 plus 1 plus 4 for the x is going to be x 1 plus 1 over 1 plus 1 minus 6. The integral for dx is going to be just x, and you have to add the c. So you see, you don't have to add c1, c2, c3, c4. No, we're just gonna add one constant c. Now simplify this one. It's going to be 2 over 4. 2 over 4, and here is x, the power 4 minus 3 over 3. And here is x cubed plus 4 over 2 x squared minus 6x plus c. So it's going to be half x to the power 4 minus x cubed, because this is 1 plus 2x squared minus 6x plus c. Check, if you find the derivative for this one, you have to go back here. If you're gonna find the derivative for this one, you're gonna go back here. Let's go to the next one. Now we're gonna find the integral for cosine over sine. And check here. We have 2 and we have quotient. So how are we gonna, if there's no quotient, to find the integral? So what I'm going to do, I'm going to say, can I simplify the way to write this one? Can I say, okay, it's the same thing, equal, it's cosine x, it's 1 over sine x times cosine x over sine x dx. Can I do that? Let's go sine times sine is going to be sine squared. 1 times cosine, go to the cosine. Now tell me, 1 over sine. 1 over sine is cosecant. So this one is cosecant x. Cosine divided by sine is cotangent x. So that means I'm going to find the integral for cosecant x times cotangent x. Cosecant x, which rule this one? Cosecant x, cotangent x. Rule number 9. Cosecant x, cotangent x, gx is going to be. So the whole thing here is going to be negative cosecant x plus c. That's it. Rule number 9, it says if you have integral for cosecant x, cotangent x, it's going to be negative cosecant x plus c. So this one is.
So I have a question. What if it's cosecant tangent x? What will happen in that case?
What about if you have cosecant
Tangent.
and tangent? You have to figure out a way because there's no rule similar to this one. These are the basic rules, okay? So yeah, this is a good question. What about if you have integral of cosecant x tangent x dx? You're gonna do the opposite thing. 1 over sine x, sine over cosine. Cancel is going to be 1 over cosine. That means it's going to be secant x dx plus the secant x dx. The integral of secant x, which will integral of secant x. We don't have the integral of secant x. That means I have to write down as so now let's check with this one. How are we gonna find the integral for x squared minus 2x4 over x to the power 4 dx? What do you think? How are we gonna do that?
Simplify.
How?
Separating the.
Yes, so we're gonna separate this one. So this one is going to be integral of x squared over x to the power 4 minus here is 2 x4 over x4 dx. Now this one is going to be the integral of 1 over x squared minus 2 dx. That means it's the same thing, the integral of x negative 2 minus 2 dx, which is equal the integral of x negative 2 dx minus 2 integral of dx. You're gonna add 1 here. So it'll be x, add 1, so it's gonna be minus 1 over negative 1 minus 2. The integral is going to be x plus c. That means it's going to be negative 1 over x minus 2x plus c. Because negative here is going to be, that's mean negative 1, bring down the x on the bottom, so it's going to be negative 1 over x minus 2x plus c. Number 10, we're gonna find the integral for x to the power 4 and secant square x dx. Secant square, you're going to use rule number 7. So I'm going to find the integral. This one is going to be the integral for x to the power 4 dx plus the integral of secant square x dx. You're going to add 1 here, so x4 plus 1 over 4 plus 1 plus the integral for the secant square is tangent x plus you have to add the c. That means going to be x5 over 5 plus tangent x plus c. That's it for this one. We're going to do the same thing with the next example. If you have sine, so it's going to be which rule we're going to use. For the sine is going to be negative cosine. That's me rule number 6. So it's going to be the integral of 2 sine x dx minus 3 minus the integral of 3 e to the x dx. Take the 2 outside the integral, the 3 outside, will give you 2 integral sine x dx minus 3 integral e to the x, and then it's going to be 2. The integral for the sine is negative cosine x minus 3. The integral for ex is going to be e to the x, and you have to add the c. That's going to be negative 2 cosine x minus 3 to the x plus c. That's it. For this example. Check this example. Find the equations of the curve. Check here. Find the equations of the curve such that the slope at each point equal x, and then find the equations at the point 2, 1. The first thing they're telling you the slope at each point for this curve equal x squared. The slope, so the slope equal x squared. We already know what's the meaning of the slope. The slope, it's mean the derivative of the function y, or for the curve y equal x squared. That's mean the slope is the derivative of y with respect to the x. The derivative of y with respect to the x equal x squared. This is the slope. Now I need to find the equations, not the slope. So to find the equations, that means I need to do the integral. So I'm going to take the integral for both sides. That means going to be the integral of dy with respect to the x is going to be the integral for x squared. But before that, before we're doing this step, I'm going to multiply both sides by dx. So it's going to be like multiply everything by dx. That means going to be dy over dx times dx is going to be equal x squared times dx. Cancel here. That means dy is going to be equal x squared dx. Now I can take the integral for both sides. That means the integral of dy equal the integral of x squared dx. What's the integral for the y, for dy? It's going to be y, because we're going to go back to the original function. That means that this is the derivative. If I take the integral, which is the antiderivative, it's going to go back to the original, which is y. Find the derivative for x squared. It's going to be x cubed over 3, because you're going to add 1 here and divide by 1 plus 2 and plus c. So this is the general equations for this slope. Then c, we can't find the c, but they're telling you then find the equations at this point. So this is x and this is y. So I have the general equations, which is x cubed over 3 plus c. I have x and y. I'm going to plug in x and y. That means 1 equal 2 cubed over 3 plus c. That means 1 equal 2 cubed is going to be 8 over 3 plus c. Now we can find the c by minus 8 from both sides. So it's going to be 1 minus 8 over 3 equals c. Let's move this one to this side. That means 3 over 3 minus 8 over 3 equals c. So it's going to be -5/3 equals c. So here is the constant c. We're just going to go back and plug in the c here. That's mean y at the point 2, 1, the function is going to be y equal x3/3 minus 5/3. At the point 2, 1. This one is going to be the equation. Find particular solution of the differential equations that satisfy the initial condition. That means particular solution with this initial condition. The first thing we want to find the general solution. So if you check here, this one is a general solution. When you put down the c, it's a general solution for the curve at any point. But this is a particular solution because we used this point. We're going to do the same thing here, but they give you a different initial condition, and there is no slope because here is the slope and here's the derivative. That's mean I'm going to start with this one to find the original function of the equations. So I'm going to say, okay, f prime to the x equal 4x. That means I'm going to take the integral for 4x. So I'm going to say, okay, to find f of x, I'll take the integral for both sides. That means the integral of f prime to the x equal the integral of 4x dx. This one is going to be f of x equal, and here is going to be 4x. You're going to add 1 here, 1 plus 1 over 1 plus 1 and plus c. That means f of x is going to be equal 4x squared over 2 plus c. That means the general equations or function is going to be 2x squared plus c. So we're done from the first step. The second step, we need to find particular solution. So what I'm going to do, I'm going to plug in. Here is our initial condition. F to the x equal y. So this is x and here is y. That's mean I'm going to say, here is my general solution, 2x squared plus c. Now f to the x equals 0 equal. X equals 0, that means 2 times 0 squared plus c. How much f to the 0? F to the 0 is 3 because it's the y. Equal, this is cancelled. So the left is c. Because 0 squared times 2 is going to be 0. That means c equal 3. So our particular solution is just going to go back to the equations and say f to the x is going to be equal 2x squared plus 3. So this is the particular solution. So this is particular solution, and here is our general solution. Okay. So let's do the same thing. Find particular solution that satisfies the initial conditions. F prime of a t. Don't confuse yourself if it's t or x. It's the same thing. It's variables. But this function is with the t. Sometimes they use it when you have time. Okay. So it's the same thing. This is the derivative. That means f prime to the t equal 12 t minus 4 t cubed. The derivative of f prime to the t equal the derivative, sorry, the integral with respect to the t, so we have to add dt here. Same thing with the previous example, we add dx. It's going to be the integral of 12 t minus 4 t cubed dt. Then this one is going to be the function f over t. Take the integral here is going to be the integral of 12 t dt minus the integral of 4 t cubed dt. That's mean f to the t is going to be equal 12 the integral of t dt minus 4. I'm taking the numbers outside the integral. 4 integral of t cubed dt. That means f to the t is going to be equal 12 t 1 plus 1, so it's going to be t squared over 2 minus 4 t add 1, so it's going to be t to the power 4 over 4 and everything plus c. Simplified. So f over t is going to be 6 t squared minus t to the power 4 plus c. Was this one with this one 6? Cancel these. So here's our general solution. This is our general solution. We need to find particular solutions at the initial condition f to the 3 equal 3. That's mean I'm gonna plug in here. So f to the 3 is going to be equal 6 times the 3 squared minus the 3 to the power 4 plus c. This one is going to be 3 equal 6 times the 3 squared is going to be 6 times 9, which is 24 minus 3 to the power 4 is 81 plus c. How much is it going to be? 51 minus 81 is going to be 3 equal
Negative 20. Well,
-3.
negative 27.
I want-
Negative 27.
So here is negative 27 plus c, and you're gonna move it here. So it's going to be 3 plus a 27 equals c. That's mean 30 equals c. So this is the c. We're gonna go back, plug in the c here to get the particular solution. So f to the t is going to be equal 6 t squared minus t to the power 4 plus 30. So this is a particular solution, and here's our general solution. The last example, find a general solution of the differential equations and check your solution. So check, this is important, because they ask you to check. So first of all, we need to find a general solution. That's mean we're going to take the integral for both sides. I'm going to multiply everything by dx. So dy over dx equal 4 x to the negative 5. You're going to multiply by dx. That's mean dy over dx times dx equal 4x to the negative 5 dx. And so these dy is going to be 4x to the negative 5 dx. Take the integral . So it's going to be y equal. Here is the 4. The integral of 4x to the power 5. So it's going to be x add 1. So it's going to be negative 4 over negative 4. We're going to add 1. We're going to cancel it. It's going to be y equal plus c. Y equal cancel 4 with negative 4. So negative x to the negative 4 plus c. Now the questions. This is the general solution. How are you going to check it's the right one? We have y equal negative x to the negative 4 plus c. This is the general solution. I need to check this is the right solution. What I'm going to do, I'm going to take the derivative here. That means dy is going to be equal negative 4 to the x negative 5 plus 0. So dy is going to be 4 x to the negative 5 because this is 0. So if I took the derivative with respect to the x, I'm going to get the same order of function. So this is how we're going to check. There is the general solution. Find the derivative with respect to the x. This one also over here. That's me going to be go back here. That's it for this.